Hi guys, Miss Malik here. Today we're doing an example from 3G. We're going to do the example on page 109, being question 1b. We're looking at finding the image of the point 1, negative 2 under a dilation of factor 2 from the y-axis. What we already know is that when we dilate from the y-axis, it affects the x values. It then follows that our x image becomes kx. K is our dilation factor. Our y image is just y. It doesn't change. We set up equations from that, being kx plus 0y and 0x plus y. We can then form a matrix. Notice how I have put in the 0y and 0x. This helps me with forming my matrix, where k is the constant by which we dilate by. So it's the dilation factor. This is now our special matrix for dilating from the y-axis, and you'll find that you get used to using this and you'll probably remember this. For the moment, it's a good idea to set up the equation, so how I've shown you. We now want to set up and solve a matrix equation. All we need to do is multiply our special matrix, where k is 2, because the dilation factor is 2, and then we have our other values that we have put in there. Multiply that by the point. Using the row by column rule for multiplying of matrices, or using the CAS, we find that the point is 2 and neg 2. Now that's all well and good, but we need to actually answer the question, and a matrix of 2, negative 2 doesn't answer the question. We need to state the image of the point 1, negative 2 under a dilation of the factor 2 from the y-axis is 2, negative 2. What that means is that the point 1, negative 2 on your original graph becomes 1, negative 2, or becomes 2, negative 2 when we dilate that graph by a factor of 2 from the y-axis. So it means on our new image graph, that point is now at 2, negative 2 instead. Let's now look at reflecting in the line y equals x. So if you think about what that actually means, what the equation y equals x is, it makes sense that our x image will be y value and our y image will be our x value. They give us the equation 0x plus y and x plus 0y. Set up a matrix, and there you have it. Let's do an example where we reflect in the line y equals x. This is example 1e from page 109 of your essential text. It says find the image of the point 1, negative 2 under a reflection in the line y equals x. So we identify the matrix to use. Our x image becomes our y value, our y image becomes our x value. 0x plus y and x plus 0y are our equations. There's our special matrix to use. Let's use it. By multiplying this special matrix for reflecting in the line y equals x by our original point, using our row by column rule, we find that we have a solution of negative 2, 1. What this tells us is that the point 1, negative 2 on the original graph becomes negative 2, 1 when we reflect in the line y equals x. This is our image point here. We then want to actually answer the question. The image of the point 1, negative 2 under a reflection in the y-axis is negative 2, 1. Let's move on from there and let's talk about translations defined by a vector. This is a little bit more tricky, but all it means is that when we go left or right or up or down on the x or y axes, it means that our x image will be the x value plus some value, which we're going to call a. So it's going to be either plus a positive number, meaning we go in the positive direction of the x-axis, or it could be a negative value, meaning we go in the negative direction of the x-axis. Our y image is going to be the original y value plus some other value, which takes us either up or down. Let's use an example to help us understand this. Let's consider a linear transformation, so linear is important there, such that the point 1, 0 maps onto 3, negative 1. That means that the original point 1, 0, when we do a transformation on our image graph, that point is now at 3, negative 1. So it's moved. And another point they give us is 0, 1. And when we do our transformation, that point moves to negative 2, 4 on the image graph. They're saying to us, now find the image of another point, so negative 3, 5, which is asking us to say, where does the point negative 3, 5 on the original graph move to once we've done the transformation. So essentially, we know that we've got to multiply a matrix by our point to get the image point. So we have some matrix, we don't know what it is yet, that's what we're going to talk about, and we multiply that by the point 1, 0, and that gives us the point 3 and negative 1. So I've just taken that from the first piece of information there, being 1, 0 maps on to 3, negative 1. So there it is there, now written in matrix form as an equation over here. My second thing is this, so I've got 0, 1 point transforming or mapping onto negative 2, 4. So it follows that I multiply some matrix by the point 0, 1, and that equals negative 2, 4. What I want to know is, what is the image of negative 3, 5? So what is it that would go on the equals after the equal sign if I had negative 3, 5 in the place of 1, 0 or 0, 1? This here, what I've written, is my x values, 3 and negative 2 of my new points, of my image points. So 3 and negative 2. On the bottom, you see my y values of my image points, negative 1 and 4. This is some matrix. So that's what I've used over here where I've said some matrix. That is what you need to multiply by in order to get to your new points. Let's see how that's going to work now. So just to recap that, with some matrix, we multiply it by the first point, we get what that first point moves to. That sum matrix we multiply by the second point, and that gives rise to the new point for that one. Sum matrix are the x and y values, x values, y values of the new points. So now, this sum matrix now becomes the matrix by which the transformation can be defined. Let's do it. So x image, y image of the point we're trying to find is going to equal the matrix that we're multiplying by there that we found from our new x and y values times the original point negative 3, 5 for which we're trying to find what it maps to. And we do row by column, so 3 times negative 3 is negative 9 plus negative 2 times 5 is negative 10. That gives us negative 19. Negative 1 times negative 3 is 3, plus 4 times 5 is 20, gives us 23. So what this actually means is that when we have the point negative 3, 5 on our original graph, after we've done some sort of transformation, we find that the new point is negative 19, 23. So this is the image. This is x image, y image. We need to answer the question, and we can do so by saying the image of negative 3, 5 is negative 19, 23. Let's now find the image of the point 2, negative 3 under a reflection in the x-axis, followed by a dilation of factor k from the y-axis. So now we're looking at a bit of a combination of transformations, and we're going to use matrices to solve this. We're going to need two special matrices here. We know that this one reflects in the x-axis, and we know that this one dilates by a factor of k. Go back a couple of slides if you want to see how we came to that. We're so close now. So from there, we want to find one matrix which includes both the transformations. So that's the first one that is for reflection, and the second one being for dilation of a factor of k. Let's multiply them together. Row by column, 1 times k and 0 times 0 is k. 0 times 0 is 0, plus negative 1 times 1 is negative 1. We use that to just find the image point as per normal. So this matrix here is a combination matrix of our dilation of factor k from the y-axis and reflection in the x-axis. We multiply that by the point, so we've been given the point 2, negative 3, and we find by using row by column, k times 2 plus 0 times negative 3 is 2k. There it is there. 0 times 2 plus negative 1 times 3 is 3. There it is there. So we need to state what this means. This means that the point 2, negative 3 becomes the point 2k 3 in the image graph. Now let's do something a little bit hard. It says express the composition of the transformations dilation of factor k from the y-axis followed by a translation defined by the matrix C equals A on B, mapping a point xy to a point x image y image as a matrix equation. Hence find x and y in terms of x image and y image respectively. And we'll leave that actually for the next one because we're running out of time.